Hello students, let's solve one more problem on the finding the Fourier series when we have the length of the period 2L. Obtain the Fourier series for the function f of x equals to, here two functions are given, 1 plus 4x by 3 in minus 3 by 2 less than x less than or equals to 0. 1 minus 4x by 3 in 0 less than or equals to x less than or equals to 3 by 2. And hence deduce that pi square by 8 is equals to 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus so on. Here two part of the function question is there. One is to find the Fourier series for the given function. Another part is deduce that. That means what? Whatever we are obtaining the Fourier series for the given function, we need to deduce that to this series. Okay, this we'll see later. First let us find the Fourier series for the given period. Okay, here the interval is minus 3 by 2 to 3 by 2. The interval of the period means f of x is defined in the interval minus 3 by 2 comma 3 by 2. Matlab the interval of a given function is minus 3 by 2 to 3 by 2. Here period of f of x equals to 3 by 2 minus of minus 3 by 2 is equals to 3 by 2 plus 3 by 2, which is equals to 3. That is 2L is equals to 3, L is equals to 3 by 2. Okay. Now we can see in the question they have given 2 f of x. One is the two functions are given. Let us take these functions as one function as pi of x, that is equals to 1 plus 4x by 3. Another function as psi of x, that is equals to 1 minus 4x by 3. Let us consider two functions. One as pi of x of a function, the second one is psi of x. Okay. Now we shall check f of x for even or odd nature. We shall check the given function, that is f of x for even or odd nature. Okay. To check the nature of a given function, here you can see two functions are there. Okay. And the interval is minus 3 by 2 to 3 by 2. Means minus 3 by 2 comma 3 by 2 means the interval is minus L comma L. Right? Okay. Here the interval is minus L comma L means we need to check the function for minus x. Since here two functions are there, therefore we need to check psi of minus x equals to. If it is pi of minus x equals to psi of x, then the given function is even, have even nature. If the pi of minus x equals to minus psi of x, if phi of minus x equals to minus psi of x, then the given function have the odd nature. Means the given function is odd function if phi of minus x equals to minus psi of x. If pi of minus x equals to psi of x, then the given function is even function. Okay, let us check that one. If phi of x equals to 1 plus 4x by 3, then phi of minus x, that is equals to, substitute x equals to minus x. Here we have obtained 1 minus 4x by 3. 1 minus 4x by 3 is, this is nothing but psi of x. Therefore, we have phi of minus x equals to psi of x. Phi of minus x equals psi of x. Therefore, f of x is even function. Okay, since the function is even, the coefficient bn becomes 0. The Fourier series of f of x having period 3 is given by, 3 means the period is 2L. F of x equals to a naught by 2 plus summation n equals to 1 to infinity en cos n pi x upon 3 by 2 plus summation n equals to 1 to infinity bn sin n pi x by 3 by 2. L is equals to 3 by 2. That is f of x equals to a naught by 2 plus summation n equals to 1 to infinity en cos, this 2 goes to the numerator, 2 n pi x upon 3 plus summation n equals to 1 to infinity b n pi x upon 3. This 2 goes to the numerator. Now a naught is equals to, okay, here we need to find the constant term and coefficient of an, because coefficient bn becomes 0, coefficient an and constant term a naught we need to find. A naught is equals to 2 by L integration 0 to 3 by 2 f of x into dx. That is 2 by 3 by 2 integration 0 to 3 by 2. F of x is, here we have chosen 1 minus 4x by 3. 1 minus 4x by 3. Why we have taken this one? Because you can see the limits are 0 to 3 by 2. Okay. 0 to 3 by 2 means for this interval we have a function 1 minus 4x by 3. Therefore we have taken this as our function. 1 minus 4x by 3 into dx. Now integrating the term, we have a naught is equals to 4 by 3 into bracket integration of x, integration of 1 is x minus that, you can see that is 4x by 3 means 4 by 3 is a constant, the integration of x is x square by 2, 0 to 3 by 2, and that is equals to 4 by 3 into bracket, substituting the limits now. 3 by 2 minus, here 2 ones are 2 2s, that means here we have 2 by 3. 2 by 3 into bracket 3 by 2 whole square minus lower limit 0, that becomes 0 only. Now we need to simplify that. 4 by 3 into bracket 3 by 2 minus 2 by 3 into 3 by 2 whole square means 9 by 4. 4 by 3 into bracket 3 by 2 minus 3 by 2 means 3 ones are 3 2s are, sorry 3 3s are, 2 ones are 2 2s are. Here we have obtained 3 by 2, that means inside the bracket we have 3 by 2 minus 3 by 2 which is nothing but 0. Therefore 4 by 3 into 0 is 0. We have obtained a naught is equals to 0. The value of a naught is 0. Next an is equals to 2 by L integration 0 to 3 by 2 f of x into cos 2n pi x upon 3 into dx. 2 by 3 by 2 integration 0 to 3 by 2 1 minus 4x by 3 into cos of 2n pi x upon 3 to dx, integrating with respect to x. Now you can see 1 minus 4x by 3 into cos 2n pi x upon 3. Product, applying the Bernoulli's rule. You know that. What is the Bernoulli's rule? Integration of Bernoulli's rule. Bernoulli's rule for integration. Integration of u into v dx, that is equals to u into integration of v dx minus u dash into integration of v dx into dx plus u double dash of triple integration of v with respect to x, and so on. Right, this is the Bernoulli's rule for integration. Using this one, 1 minus 4x by 3, that is u into integration of v. 1 minus 4x by 3 into integration of cos 2n pi x upon 3 is sin 2n pi x upon 3 upon 2n pi by 3 minus u dash. U dash means derivative of this term. Derivative of 1 is 0. Derivative of minus 4x by 3 is minus 4 by 3 into bracket. Keeping 1 upon 2n pi by 3 as a constant, integrating sin of 2n pi x upon 3, that is cos 2n pi x upon 3 upon 2n pi by 3 between the limits 0 to 3 by 2. 4 by 3 into bracket 1 minus 4x by 3 into 3 upon 2n pi into bracket, that is 2n pi by 3 goes to the numerator, sin of 2n pi x upon 3 plus, that is minus into minus, plus 4 by 3 into 2n pi 1 into cos 2n pi x upon 3 is minus cos 2n pi x upon 3. Here we have minus cos 2n pi x upon 3, and 2n pi by 3 into 2n pi by 3 is 4n square pi square upon 9 between the limits 0 to 3 by 2. Now you can see the first term becomes 0 because we have sin 2n 2n pi is equals to 0. the first term vanishes. We have left with second term. And 4n square pi square by 9 goes to the numerator. 4 by 3 into bracket minus 4 by 3 to 9 upon 4n square pi square cos of 2n pi x upon 3 0 to 3 by 2. 4 cancels. Next 3 into 3 9. This 9 with this 9 cancels. We have minus 4 upon n square pi square into bracket cos of 2n pi 3 by 2. That is substituting the limits. X equals to 3 by 2 upon 3 minus cos 2n pi into 0. Minus 4 upon n square pi square into bracket cos n pi 3 by 2 upon 3 by 2 minus 1. Or here 3 by 2 cancels. We have cos n pi, and cos n pi is minus 1 raised to n. That is n is equals to 4 by n square pi square into bracket minus 1 raised to, okay, here you can see minus 4 upon n square pi square into bracket minus 1 raised to n minus 1. Next, taking minus common from this bracket term and multiplying with this, we have 4 upon n square pi square into bracket 1 minus of minus 1 raised to n. That is equals to 4 upon n square pi square into 2. 2 is, this is nothing but this is the value of this term. How I obtain this one? You can just have a look here. 1 minus of minus 1 is equals to 0 if n is even. 1 minus of minus 1 raised to n equals to 0 if n is odd, even. 1 minus of minus 1 raised to n is equals to 2 if n is odd. That is 1 minus of minus 1 raised to n is equals to if n is odd. Now taking n is 1, that is n equals to 1, 3, 5 and so on. 4 upon n square pi square into 2, that is equals to 8 upon n square pi square. An is equals to 8 upon n square pi square. Now we have a naught is equals to 0, n is equals to 8 upon n square pi square, and bn is equals to 0 because even function is even function. Therefore equation 1 becomes f of x equals to 0 plus summation n equals to 1 to infinity 8 upon n square pi square into cos of 2 n pi x upon 3 plus 0. That is nothing but f of x equals to 8 upon pi square summation of n is equals to 1, 2, 3 to infinity 1 by n square. 8 by pi square I have taken outside the summation. 1 by n square into cos of 2 n pi x upon 3. This is the Fourier series, one part of the solution. Next they are asking to deduce the series. To deduce the required series, let us put x equals to 0. That is f of x equals to 1 minus 4x by 3. That is 1 minus 4 into 0 by 3, which is equals to 1. That is f of x equals to 1. Substituting that, 1 is equals to 8 by pi square summation of n equals to 1, 3, 5 to infinity. Because we have seen that when n is equals to odd, we have the value 2. Therefore, by taking n odd values, 1 by n square into cos of 2n pi into 0. Because x equals to 0, we are substituting upon 3. Pi square by 8 is equals to summation n equals to 1, 3, 5 and so on up to infinity 1 by n square into 1. Because it is cos 0. Cos 0 is 1. That is equals to summation n equals to 1, 3, 5 up to infinity into 1 by n square. Now substituting these odd values here and transferring 8 by pi square to LHS, we have pi square by 8 is equals to 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square plus so on. This is a solution for the given question.